Hello, welcome back. All right, today we're going to start looking at perfect squares and how to use them when solving equations. So let's jump in with what on earth a perfect square is. Perfect square, great shape, classic, find it everywhere. Looks like this. This one's not perfect, but we're going to imagine that it is. What does it have? It's got four corners. It's got four sides. And we're going to be really looking at the sides today, not so much the corners, but we can talk about it anyway. What do we notice about all the corners? They're all the same. How many degrees is each one? Well, we call them right angles, and a right angle is 90 degrees. Okay. We have four sides, and they're also all the same. They can be any length as long as they are all equal to each other. So, what does that help us with? Let's find out. When in mathematics we talk about perfect squares, we're often talking about numbers that are perfect squares. You think numbers and squares, how could they be the same? Like this. If I have the number, let's say 3, and I want to square it, I put this little 2 there on the top of it. That's my square. What that's telling me to do is to take this number 3 and turn it into a square. You probably ask yourself, Mr. Mott-King, how do you take a number and turn it into a square? Like this. I take my side. I'm going to call it 3. If this is one side of my square, if I turn it into a square, all the sides also need to be of length 3. So I can draw them out like so. And it's not perfect, but it'll do. How's that? That's better. So now each side is 3. I've squared my 3. I've taken the 3, turned it into a square. Well, what number does that make? Well, let's find out. If one side is 3, the other side is 3, to find the area of that square, that's what this is going to be telling us to do. To find the area of the square, I need to break it up. This top side now shows 3. 1, 2, 3. And I can do the same thing across this side here. 1, 2, 3. If I count all the squares inside, you can probably already see right now that there are 9. 1, 2, 3, 4, 5, 6, 7, 8. So 3 squared is the same as 9. And that's what we're going to be doing here to show how to square a number. What you might be noticing already is that it's just 3 times itself. 3 times 3 is 9. So that's what we're doing. What about some other ones? Another example of a square. Well, that was 9. What if I did 5? What would be 5 squared? I could turn it into a square with sides 5 by 5, cut it up, and count all the boxes. Or what I can see here, this number at the top, this 2, this is called an exponent. It's telling me how many times to multiply. It's not 5 times 2, it's 5 times itself twice. So I can break this up into 5 times 5. If you don't know what 5 times 5 is, you can use a calculator. That's totally fine, but I can tell you now, it's 25. The perfect squares are numbers that are really good to have memorized. Normally, I never say memorize anything. The perfect squares, remember, they're going to come in handy. Okay. Let's do a quick quiz. How about it? I'm going to make a table with some numbers, and you're going to help me fill it in. So if I start with the number, and then the square. Here we go. First one is 2. What's the square? 5. Oh, we just did 5. We can do that one. What if the square is 81? What if it's 6? And then here's a tough one. What if it's 196 down here? Let's see. Can we fill in this table here? Let's see. 2 is the number. I want to know what that is. What's 2 squared? 2 squared is 4. 2 times 2 is 4. What about 5? We just did 5. 5 squared is 25. Now here, I want to know what number times itself makes 81. Do we know? Tricky one. But it's 9. The way I know that, well, I have to work backwards. Instead of doing this 5 squared, I'm going to find the square root. It's called a radical. And that's equal to 9. Okay. What's 6 squared? That's 6 times 6 is 36. And then 196 is 14. I know that because, well, I had to memorize them, as I hope you will too one day. So that's 14. Okay. These are just quick examples of what's going on here. So, next thing I need to talk about is when we use this in algebra. So, when we have a variable squared, and we want to find out what the variable is, it's a little bit trickier. So I'm going to write down a problem. Let's see if we can figure it out together. I have my number squared is equal to 36. Well, we just did an example with the number 36. So what was it? What times itself makes 36? We find the square root of 36. And you might be thinking to yourself, well, Mr. Mott-King, this is really easy. It's just 6. And I would tell you that you're half right. 6 is indeed the answer because I can show you 6 times 6 is 36. That is correct. X times x is 36. 6 times 6 is 36. X has to be 6. But there's this really strange thing that happens with exponents and perfect squares is that there's another answer. There's another number that x can be to make it 36. It's another thing that we can multiply by itself to make 36. And that number is the opposite, negative 6. If I do negative 6 times negative 6, well, what happens when I multiply two negative numbers? It becomes a positive. And so there you go. We've got another number that when multiplied by itself makes 36. So what we do here is x equals two numbers, positive and negative 6. When we're solving for x, it's got to be both. Okay. Let's do an example of a problem involving exponents. Here's the problem. We've got 6x squared equals 24. If you remember, I've talked about this often. Order of operations. We do it in reverse here. I got my line. I've got 6 times the number, and I'm going to square that number. Exponents are going to come last. So the first thing I'm going to do is get rid of this 6 times. Do the opposite. Divide by 6 on both sides. 6 divided by 6 cancel. 24 divided by 6 is 4. I'm left with x squared equals 4. So I need to know what number times itself equals 4. There's two answers, don't forget. So I take the square root of both sides. And I get x equals, well, one of the answers is 2. But remember, we have to show both solutions, plus and minus. And there would be our answer. X is 2 and negative 2. We could check our work if you like. If I put in 2 here, 6 times 2 squared equals 24. 2 squared, 4. 6 times 4 is 24. Same thing with the other solution. I could do 6 times negative 2 squared equals 24. Negative 2 squared is positive 4, once again. 6 times 4 is 24. So they both work. That is the indeed solution. Okay. Let's do another one. This one's going to be a little bit bigger. We're going to have more operations involved than just multiplication and exponents. The last problem, I swear. So for this problem here, it's going to be quite a few steps. And we're going to start with this 4x squared plus 12 is equal to 412. All right. Let's look at the operations that we have in our equation, and then we can start undoing them. So I see already I've got a plus, I've got a little multiplication here, and I've got an exponent. So there's 3 operations happening all on this side. We're going to undo them piece by piece, and we're going to do it in that order that is opposite the regular order of operations. Okay, so I'm going to write down those letters again. Sad, Meg. Okay. Subtraction, addition, division, multiplication, exponents, and groups. So we've got addition. That's going to be our first thing to undo. So I'm going to do the opposite and subtract 12 from both sides. Easy enough. 12 minus 12 is nothing, so I'm left with 4x squared equals 412 minus 12. I'll give you a second. That's right, 400. Next thing, do I take the square root of this? No. I have to divide first. Division comes before exponents. So I'm going to divide. I'm going to divide both sides by 4. That's going to leave me with x squared equals, well, what's 400 divided by 4? It's 100, right? Are we done? Almost. This is telling us x times x is equal to 100. I just want to know what x is. So we think, what times itself is 100? We find the square root. Again, use a calculator, whatever you need. We want to know the square root of both sides. The square root of x times x is just x. The square root of 100 is 10. Remember, 10 is just one of the answers. So let's make sure to show both plus and minus 10. And there's your answer. Congratulations. You made it through. Stay smart. Stay safe. See you next time.